The application we'll be talking about now is impact resistance and shock absorption. Using Connex technology, we can actually print rubber-like materials together with rigid materials in one printing build, and this gives the designer a huge advantage in that he or she can decide where they would like to have a protective layer of coating on the given part and what width, in terms of what width of rubber material is desired for that part. Drop tests and vibration damping are rendered possible with the help of Connex technology.
Shock absorption and impact resistance are key elements that need to be accounted for when designing consumer goods and electronics, tools, and products that have parts at risk of breaking by means of impact or shock. This tape measure is designed for both general purpose uses as well as industrial uses, such as at a construction site. With these applications in mind, the tape measure is expected to be dropped or otherwise impacted in addition to normal wear and tear. While prototyping the design with Objet 3D printing, designers were able to perform impact and drop tests to find weak points in the design. Once identified, structures like ribs and supports were added to prevent cracks or breaking. The transparent shell also allows viewing the internal dynamics of the assembly, such as the rotation of the measuring tape spool and actuation of the tape release button. This gives a better understanding of the moving parts, interaction, and the ability to troubleshoot any conflicts in the design. The tape measure shell is assembled using self-tapping screws. The design for these screws can be perfected to make sure that the material will not crack or deteriorate as the screws are tightened into place. In addition, a rubber overmold was designed into the shell to provide enhanced durability by absorbing shock from impact and to avoid cracking the rigid part of the shell. The overmold feature also gives better aesthetics to the product and provides better surfaces for the user to grip. The tape measure shell also needs to withstand the tape retracting at high speed. When no more tape is left to retract, the blade contacts the lip of the shell and due to its momentum could actually crack the rigid shell. So instead, the overmold has been designed to cover this edge and absorb the shock from the tape measure blade. By optimizing the thickness or the rubber at this location to approximately 40 thousandths of an inch or 1 millimeter, the overmold acts as a bumper and eliminates the risk of damage to the rigid part of the shell. The tape release button was printed in Virogray material, which best simulated the properties of plastic which would be used to manufacture the final product. This moving component of the design is crucial to the functionality of the product, so it is imperative that this hinging part works without fail. A rubber stopper printed as an overmold in Tango Black Plus material to simulate the production silicone acts as a wedge to restrict movement of the measuring tape spool when the button is not pressed. The Tango Black Plus material with Shore A value of 27, which is very pliable yet strong, and releases or stops the measuring tape on command. To sum it up, the tape measure is an excellent example of the use of Objet 3D printer to simulate and test design of products that involve shock absorption and impact resistance.